First of all, let's have a quick look at the main sections of a mixing desk. Then we'll go back and look at each part in more detail. Each audio source, a microphone or keyboard for example, comes into the mixer through a channel strip, which has a set of controls to modify and balance the sound. Channel strips take up most of the space on the mixer because there's one for every audio input. Sometimes it's good to be able to control the level of a whole group of sounds as if they were one. This is what the subgroup section does. You could, for instance, connect all the input channels from a drum kit to a single group fader, which would let you fade all the drums up and down all together. The master section is where the finished mix ends up. There are controls for headphone levels, the control room sound, and of course the main mix. You'll normally have inputs and outputs for auxiliary sources like tape decks and CD players here as well. It doesn't matter how big or small a mixer is, and it doesn't matter how expensive it was. They all do the same thing. An audio mixer brings all the parts of a performance together, blending and processing them so that the final sound makes sense to the audience and is good to listen to. Until you get to know how to use a mixing desk, it can seem like a confusing array of knobs and faders, but the good news is that mixers are divided into simple groups of controls that are quite easy to understand. And the reason for all those knobs is that every sound coming into the mixer has a complete set of controls to itself, called a channel strip. Each channel strip is the same as all the others, so once you know how it works, you practically know how the whole mixer works. The sensitivity of the mixer to incoming sounds is set with the channel gain control. Low-level signals from microphones will need more gain than stronger signals from keyboards and samplers. It's really important to get the gain setting right, because if it's too low, the mixer will be noisy, and if it's set too high, you could get distortion. And don't forget that you're not just dealing with one channel. If your gain settings are wrong on all of them, all the problems are added together in the final mix. The high-pass filter cuts out very low frequencies, but lets all the others through without affecting them. You can use it to clean up boomy instruments, or to take out rumble from people jumping around on stage, air conditioning, or even tube trains. You probably wouldn't use a high-pass filter on a bass guitar or a bass drum. Used appropriately, a high-pass filter can make your mixes sound cleaner and less muddy. A mixer's EQ section is crucial to the mixing process because it has the power to completely change the character of the sound. But unless you want to use EQ as an effect, you should use it in moderation. The best EQ settings are always invisible to the user. EQ is normally split into bands, each controlling a range of frequencies. A simple two-band EQ is just like treble and bass control on a hi-fi amplifier. More sophisticated EQ sections have more bands. Small to medium mixers often have three-band EQ with separate controls for high, mid and low frequencies and the ability to move the mid-band so you can home in on the exact frequency you want to cut or boost. Auxiliary sends control the amount of signal sent to external effects from each mixer channel. In a live setup, they're also used to set up a monitor mix, which is how musicians on stage get to hear what they're playing. You use the pan control to set the position of an instrument or microphone in the stereo mix. It's also used in conjunction with the routing selectors to send audio to group faders and outputs. The routing selectors determine which of the mixer's outputs or subgroups a channel's audio is sent to. Routing switches are normally used together with the pan controls, which send audio proportionately to odd and even subgroups. The solo button is used when you need to hear what's going through a single channel in isolation. PFL isolates any signal coming into the mixer independently of all the other channels. It's useful for setting the input gain and EQ. You can use it for troubleshooting as well. If there's something nasty in the mix, you can use PFL to find where it's coming from. PFL solos the sound before it goes through the fader, which means that the level you hear is not linked to the position of the fader and doesn't change when the fader moves. Channel mute turns the channel on or off. It's a good idea to mute a channel when it's not in use, especially when it's connected to a live microphone. For live theatrical work, you can pre-configure different scenes on channels and mute them until they're needed. Faders set the level of an input signal within the mix. It's important to understand that faders do a different job to the channel gain controls. A gain control deals with a very wide range of signal levels and makes sure that approximately the same amount of signal comes into each channel strip. The fader adjusts the level of audio relative to the other channels. You shouldn't use faders to compensate for a weak input signal. There's a useful rule of thumb here. Aim for unity gain throughout the mixer. In other words, the mixer isn't an amplifier. Now we're going to spend some time looking at the process of mixing in more detail. You'll learn how to connect instruments and microphones, how to add effects, how to apply equalization, and how to set up the mix itself. Most mixers have a combination of mono and stereo inputs. You'll normally connect microphones to the mic-in socket, which will be an XLR connector. Mic inputs are almost always mono, and they're very good at dealing with the low-level signals that you get from microphones. Line inputs are for keyboards and sound generators, like samplers and MIDI modules. It's not a good idea to use line inputs with microphones because the signal levels are much lower than line inputs are designed for. Usually, keyboards and MIDI units have stereo outputs. It's normally okay just to use one leg of a stereo pair and plug it into a single mono channel on the mixer. It's often only pseudo-stereo anyway, but sometimes a keyboard patch only sounds right when it is in stereo. For sounds like these, you've got a choice of using two mono channels on the mixer and panning them left and right, or using a stereo input. Stereo mixer channels are just like mono ones, but they tend to be a bit simpler. The insert point is for connecting signal processors like compressors and limiters. Although there's often only a single socket in the channel strip, the insert point is both an input and an output, and you need a special cable to connect to it. The important thing to understand here is that all the signal comes out of the insert point and passes through the external device and then comes back into the channel. It's as if the external processor was part of the channel strip. The direct out is for sending audio from the channel to a multi-track tape recorder or effects device, without it being mixed with audio from any other inputs. Condenser microphones need power to make them work. Some work with batteries, but most of them can also use the mixer's phantom power. Just switch on phantom power for any microphone that needs it, but make sure you don't activate a global phantom power switch if you've got unbalanced sources connected to a mic input. You could cause serious damage if you do this accidentally. The master section is where you control and monitor the mix and where you send it to its various destinations. Mix outputs control the level of the final stereo mix. You may find your mixer has mixed insert points, which would be useful if you needed to connect signal processors across the whole mix. The control room or engineer's outputs are not sent to the auditorium but are normally used for an engineer's headphone feed or loudspeakers in a control room. You can monitor the whole mix from here, or any solo, submix from a group or 2-track tape return. If you want to play music to the auditorium before the live show, plug your stereo music source into the 2-track tape returns. The auxiliary masters control the level of audio being sent to the external effects units. This audio is actually the mixed audio from the auxiliary sends on the input channels. AFL lets you monitor the signal as it leaves the auxiliary masters. Meters normally show the mix output levels, but when you press the solo button they show the level on the solo channel. Stereo returns are for the outputs from effects units. Audio from stereo returns can be routed to the stereo mix or to subgroups without using up valuable input channels. This is one of the easier things to explain. The headphone socket is for headphones. Make sure you've got closed headphones and not the open type. Open headphones don't give enough isolation from ambient sounds. Effects units and signal processors are really quite different things. Effects only work on the part of the signal that you send to them, which is then mixed back with the original dry signal. But signal processors work on the whole signal, so the whole signal has to be extracted from the mixer, fed through the processor, and then put back into the mixer. So the basic rule is, effects units are connected to the mixer via auxiliary sends, and signal processors are connected to insert points. Graphic equalizers can cut or boost a large number of fixed frequency bands. They're called graphic equalizers because you can see the shape of the EQ curve from the position of the controls. Even though the frequency bands are fixed, there are enough of them for you to be able to focus fairly precisely on one or more problematic frequency. They're especially useful for isolating and notching out feedback frequency hotspots, and for generally improving the sound of a live venue. Parametric equalizers are similar to the swept band EQ sections on a mixing desk, but with an important extra feature. You can vary the width of the swept frequency band. This is useful creatively and for correcting sound. You might, for example, have to fix a nasty resonance in an acoustic instrument. With a parametric EQ, you can tune the EQ exactly and narrow the frequency band until it only affects the sound you want it to. Noise gates only allow sound over a certain level to pass through and mute everything else. Normally you'd set this level or threshold so that you get all the sounds you need but none of the low-level but still annoying background sounds. When you have a lot of channels in use on a mixing desk, they all contribute unwanted noise to the final mix. By putting a noise gate on each input source, it's a bit like having an automatic mute control, which comes into play whenever there's a quiet bit. Gates are especially useful for drums, where they can stop the hi-hat spilling into a tom-tom microphone, for example. A compressor reduces the difference between the loudest and softest parts of a performance. It's as if someone was listening to the performance and moving a fader to make the levels constant. Below an adjustable threshold, audio passes through the compressor unchanged, but above the threshold the compressor will reduce the gain. The amount of reduction is called the compression ratio. Compressors are used a lot with singers to give a controlled, produced sound, and bass guitarists to give the performance more punch.
Tossed aside, never knowing how to break free.
Limiters are like compressors, but they won't let anything at all go above the threshold. They're extremely useful in live performances because they can save the mix from nasty overloads that might happen too quickly for a human engineer to respond to.
knowing how to break free.
To set up a signal processor, connect it using an insert cable to an insert point, and remember that it can be a mono, group or mix insert point. Set the processor to unity gain, i.e. with no additional gain and no cut either. Adjust the signal processor to give the sound you want. If the processor settings have altered the mixer input and output levels, readjust them so that you have 0 on the meters. This is where we're going to look at how you connect things to your mixer. You may already know a lot of this stuff, so you can quite safely skip this section if you want to. Microphones use balanced XLR cables. Don't use line inputs for microphones. The plugs won't fit, and even if you use an XLR to jack adapter, the levels won't match. A direct injection or DI box turns a low-level unbalanced signal, which might be from a guitar or bass, into a balanced one that can be plugged into XLR microphone inputs. Balanced signals can travel much further than unbalanced ones without losing out to noise and interference. Of course, you might want to just mic up a guitar amp for a more authentic sound. The best DI boxes are active and use phantom power from the mixer. Although you can connect guitars to line inputs, there will always be an impedance mismatch, which isn't good for the sound. Most instruments that you can't hear at all unless you turn them on have line-level outputs, and so do CD and mini-disc players, DAT machines and wireless microphone receivers. Mono outputs can go straight into a mono-line input on the mixer. You can plug stereo line sources into the left and right inputs on a stereo channel, or into two adjacent mono channels, as long as you pan them hard right and left. Effects units need to get a signal from the mixing desk and be able to send it back so that it can be part of the final mix, so they have both inputs and outputs. Connect the mono input of your effects unit to a post-fader auxiliary output. The left and right outputs from the effects units should be connected to a pair of stereo returns, or stereo inputs if there are no stereo returns available. Remember that stereo channels have fewer facilities on them, so if you need complex EQ, then use a pair of mono inputs. Connect signal processors like compressors to the insert jack. You'll need a special insert cable which allows the audio signal to be sent and returned to the mixer using only one connector. The cable itself has the insert jack at one end and splits into two separate legs, one with a plug for the input to the processor and one with a plug for the output. Now we're going to look at the things that sit on the output from the mixer, starting with amplifiers. There are some important differences between PA amplifiers and hi-fi equipment. Although you could probably get by with a hi-fi amplifier in a very small venue, it's much better to have one that's built for the job. It'll be more robust and will give you the headroom you need to cope with everything you throw at it. Surprisingly, you're more likely to blow up loudspeakers with an underpowered amplifier than an overpowered one, because when an underpowered amp goes into clipping, it produces extremely harmful high frequencies, which can send even the best tweeters into oblivion. You really need dedicated PA speakers for live work. They're built to take knocks and all sorts of abuse that would instantly pulverise domestic loudspeakers. There are all sorts, and you still need to treat them, as well as your ears, with some respect. When you're choosing headphones, avoid open-backed ones and make sure they're comfortable. Mixers can only work with audio that's at the right level. The input gain control boosts or cuts the incoming signal so that it falls within the range of levels that the mixer can cope with. All electronic devices, including mixers, produce a low level of electronic noise. Well-designed mixers minimize the noise problem, but you can never get rid of it completely. So what you have to do is make sure your mix is properly set up to get all the audio you want in the final mix and as little noise as possible. When you're setting levels, always aim to get the highest level before distortion sets in, and then back off a little bit, just to make sure you've got some headroom if you need it. Here's the exact procedure for setting up the gain on a Soundcraft mixer. Press the PFL solo switch on the input channel you're working on. Adjust the input gain control until the meters are in the yellow part of the scale, that's between 3 and 6. This leaves you with around 10 decibels of headroom to play with. Now release the PFL solo button. Then just repeat this process for all your other inputs. Faders are for making fine adjustments to the sounds in your mix and give you a handy visual idea of what the mix levels look like. It's important to have your input gain setting set so that you can keep your faders around the 0 mark, for 2 reasons. First, faders are more sensitive to movement at the bottom of their range, and second, because you need to have some room above the current setting so that you can turn up the level quickly if you need to, maybe for a guitar solo. The master output levels should be set around 0 as well. This will give you the maximum fader movement for fading out your mix. And if you set the faders much below 0, then the meters aren't going to give you much information, because only the first few LEDs will be in use. EQ is an important tool when you're setting up a mix. You can use it to correct sounds from cheap microphones and to compensate for acoustic problems at a venue. EQ can be really effective, but to make it work you have to use it with restraint. First, try to get the sound right at the source. Use the best microphones you can get and learn to position them so that singers or acoustic instruments sound right before you feed them into the desk. Of course, things are never perfect at a live gig, and sometimes EQ is the only weapon you have to fix the sounds coming off the stage. Fixed EQ controls are just like the ones on a domestic hi-fi amplifier. In the center position, they don't have any effect. Turn them right to boost the signal, and turn them left to cut it. There are only 2 bands, high and low. As EQ sections go, this is a pretty simple one to operate, but don't be fooled by the simplicity. If you overuse this kind of EQ, you could easily make things worse rather than better. There's a drawback with fixed EQ, which is that if you want to work on a particular sound, the punch of a bass drum or the ring of a cymbal for example, you won't be able to focus the EQ on the exact frequency. In fact, you can only boost or cut a pretty huge part of the audio spectrum, and you'll end up changing much more of the sound than you might want to. On the other hand, if you just want to add a little warmth or sparkle to a sound, then as little as a quarter of a turn of the knob should do the trick, especially with low frequencies like bass guitars and bass drums. You can keep yourself out of trouble if you remember, always cut rather than boost where possible. A mid-sweep equalizer can also cut and boost frequency bands, but the mid-band is movable, so it can be tuned in to the frequency you're working on. This makes it a much more versatile type of EQ than fixed band. Here's how you use it to get rid of unwanted sounds. Turn the gain up on the mid-frequency section. Sweep the frequency around until you locate the aspect of the sound you want to modify. Find the exact spot where it sounds most annoying. Now rotate the knob from boost to cut. Choose the amount of cut that sounds best. Even a small amount of cut can have a hugely beneficial effect. Remember that EQ is actually frequency selective gain. Whenever you're boosting a frequency band, there's an increased danger of feedback, so just make sure any channels with open but unused mics are closed, and that the amplifier levels in the auditorium aren't too high. There's a problem with mixing instruments in a live venue. Unless it's a string quartet or jazz ensemble, the music will sound very different to a studio recording. This isn't necessarily a bad thing, but it's quite likely that the sound will simply be dull and lifeless, despite the best efforts of the musicians. So it's important to be able to put some of the polish back into the sound. It's always there in lush productions that come out of the recording studio. You can do this using effects, and we're going to look at a few of them now. Reverb is the most commonly used studio effect, and it's probably the most essential. It simulates an acoustic environment that's not available physically at the time. Different types of music and different types of instruments work best with specific types of reverberation.
Don't take no notice, keep walking by.
There's no substitute for experimentation here, and it's a good idea to listen closely to recordings to see how reverb and other effects have been used. Things are a little more complicated in a live venue because it will have its own reverb characteristics. Unfortunately, you can't artificially tone down the reverb in a venue that has too much of it. What you have to do is find the best combinations of levels, EQ, and artificial reverb to complement the natural acoustics. Here's a basic rule to get you started. Don't put much reverb, if any, on low-frequency sounds like bass guitars and bass drums. All you'll end up with is a muddy sound, completely lacking any sort of punch. Delay is often used to thicken a sound by taking the original audio, delaying it by a very short amount, and then mixing it back with the original. It's sometimes used in a live context to simulate double tracking in a studio, where the same vocal line is sung twice or more and then mixed together. Echo is a longer delay that you can use on vocals, guitars, or even flutes. These days, the length of the delay is often matched to the tempo of the song. Chorus and flanging are produced by very short delays. Flanging also uses feedback to give a deeper, richer effect. Chorus is used a lot on guitars, and flanging is very effective on electric pianos. Both work very well on synth sounds, especially artificial strings, where modulation, which is a slow variation of the delay time, can create a swirling effect full of movement. Remember, if you're using a mono PA system, make sure these effects sound okay when they're not in stereo. Sometimes you can lose the effect, or even the whole sound, unexpectedly because of this. To set up an effect unit, first connect it to the mixer. Go back to the Input Devices section to see how to do this. Set the unit to give a full wet signal. Go to the channel you're working on and set the effect's post-fade auxiliary send to maximum. Select AFL on your auxiliary master and set it so that the meters read 0.
Tell us your secret, so won't you fly, my butterfly.
Adjust the input level on the effects unit until its meters read 0. If you do this, you can use the mixer AFL meters to monitor the effects levels because you'll have calibrated them together. Release all AFL buttons and adjust the effect return controls until the effect sounds right in the context of the whole mix. Effects units are always used on post-fade auxiliaries, so that the amount of signal being sent to the effects unit is proportional to the position of the fader. If this didn't happen, you'd end up still hearing the effect, even when the dry sound was faded out. So far, we've been looking at how to set up a mixer in a live venue. Now we're going to find out how to actually do the mix. It's important to choose the right microphone for the job. There are several different types, and each has a different role to play in a live performance. Dynamic microphones are tough, tend to be relatively cheap, and don't need an external power supply. They're ideal for all-round use, and especially where there are high sound pressure levels. But they're not as sensitive to high frequencies as condenser microphones. Condenser microphones are much more sensitive to low sound levels and to higher frequencies. They need power to make them work. Some work with batteries, but most of them can also use the mixer's phantom power. Different microphones tend to have different pickup patterns. Omnidirectional microphones are equally sensitive to sounds from all directions. You'd use an omnidirectional microphone for groups of vocalists, audiences, and ambient sounds. But you have to be careful with them because they tend to encourage feedback. Cardioid microphones have a heart-shaped response, making it most sensitive to sound from the front and sides. They're good for most basic uses and, because they don't pick up much sound from behind, can be used to avoid spill from other instruments. Hypercardioid microphones are even more directional. They're great for live vocals because they avoid spill and minimize feedback. Don't skimp on cables and connectors. As ever, your signal is only as good as the weakest component. It's worth making sure that your connectors are in good physical shape as well, because you can guarantee they'll get a few knocks during the setup and the performance. Always use balanced audio connectors for microphones and very low-level signals. Keep cable runs as short as possible. It's a good idea to use a multi-core cable and a stage box to keep things tidy. If your mixer has an external power supply, keep it well away from the console to reduce the risk of hum. If audio signal cables and mains cables have to cross over each other, arrange them at 90 degrees, again to reduce hum. Where the venue has three-phase power, try not to share the same phase as the lighting controllers, which can be electrically very noisy. Don't disconnect the mains earth to get rid of hum. This can be extremely dangerous. What you can do is disconnect one end of the shield in an audio signal cable to see if this helps. If you're using wireless microphones, put the receiver on stage and run the audio back to the mixer at balanced microphone level using a DI box to minimize interference. Keep unbalanced insert leads away from the mains and make sure they're shorter than 2 meters. Turn down the amplifier gain before you switch the mixer on. Set all the channel EQ controls to their flat or neutral position and find the optimum input gain for each channel using the input gain controls, pressing the solo button for the channel you're working on.
Got to know me. Would it shatter your pride?
Decide whether low-frequency background noise is a problem and, if it is, switch in the high-pass filter on each of the microphone channels. Remember, don't use the high-pass filter on bass guitars or kick drums. Feedback is the ever-present hazard in live venues. Here are some ways to minimize the problem. Turn down or mute any microphone channels not in use. Not only will this reduce feedback, but it'll stop the microphone picking up spill from the backline and stage monitors, and you'll get a clearer sound. Move the PA speakers as far as possible from the microphones. It's worth looking at the back of the stage, because if it's hard and reflective, sound from the rest of the room will bounce off it and into the microphones. You may be able to hang some deadening material to damp things down a bit. Don't boost EQ if you don't have to. Feedback loves narrow boosted frequency bands, and it doesn't do much for the sound either. Always use EQ for fine-tuning rather than for dramatically modifying the sound. Try to put stage monitors where they won't be picked up by the vocal microphones and have them as quiet as you can without affecting the performance. There's no such thing as the perfect venue. Every auditorium offers a different challenge to a sound engineer. Next, we're going to run through the process of nulling out room acoustics. What we're trying to achieve here is to make the room sound neutral, so that the audience can focus on the music and not the wayward acoustics of the venue. Ringing out the system before the sound check is a good way to reduce the danger of feedback. You need to remember that during the process of ringing out, you can cause severe feedback which can damage loudspeakers, so be very cautious when turning up levels. Here's how it's done. Put a graphic equalizer into the mixer's mix insert points. Set all the graphic equalizer's controls to 0, which means that they'll be in the straight line centered on 0. Turn up the amplifier volume until you can just hear the sound start to ring. Turn back the volume slightly so that the ringing doesn't turn into feedback. Starting from the left, adjust the first graphic EQ control to maximum. If the system doesn't feed back, then this isn't a problem frequency, so put the control back to 0. If you do get feedback, reduce the gain at that frequency. Do this again for all the other frequencies on the equalizer. Test any effects connected to the system and check that you've got the right balance between the dry and affected sound. Try to put the mixing desk in a position where you'll be hearing the music from where the audience does. When you've set up, switch the power amps on last to protect the loudspeakers from any loud thumps and buzzes as instruments are plugged in. Don't put vocal microphones directly in front of the drum kit or a guitar amplifier. Make sure nothing gets in between the loudspeakers and the audience. Aim them down towards the listeners, don't point them at the walls. Set up the vocal levels first. There's no point getting a great drum sound if you can't hear the vocals over the drums. Keep the vocals panned towards the centre of the mix. It'll sound more natural and you'll get more level before feedback sets in. Go easy on the reverb. Most venues will have too much of it anyway, and if you use it excessively, you'll lose intelligibility in the vocals. Don't use any reverb at all on low-pitched sounds like bass, kick drums and tom-toms. If you put too much bass guitar or kick drum through a small PA, you can overload it. This leads to distortion which can ruin the vocal sound. If you come up against this, try rolling off some of the low-end frequencies. This will give you a higher subjective sound level. Keep the backline levels down. Let the microphones, mixer and PA speakers do the work. Leave some gain in hand so that you can wind up the levels gradually during the show. Sometimes groups of instruments or singers can be treated as if they were one sound source. You may find that it makes sense to sub-mix these groups of sounds together on a separate small mixer before bringing them into the main desk.
Every day, all over the world, sound entertains, delights, informs, motivates, thrills, moves, and inspires. And wherever sound matters, you'll find the products of the Harman Pro Group, helping people create, reproduce, and transmit music and the spoken word. Each of our best-of-breed brands is universally respected as a leader in its category. Altogether, we have 2,500 professionals committed to designing, engineering, and manufacturing the very best sound system solutions for every conceivable professional application, environment, and budget. With sales approaching $500 million, the Harman Pro Group is quite simply the world's largest professional audio company. We have maintained this leadership for nearly 6 decades with technological breakthroughs and industry firsts that have defined and redefined the state-of-the-art for movies, recordings, and concert sound. Indeed, it's hard to imagine a single major event in entertainment history without groundbreaking performances by Harman Pro Group products. Today, we're building on this heritage and leading the way into the future with our unmatched commitment to innovation and excellence. As part of Harman International, the world leader in digital infotainment systems, we're able to leverage a $100 million R&D budget and the collective purchasing power of a multi-billion-dollar company to ensure your material and component investment delivers the highest performance and the absolute highest value. You can't get that kind of technology, that kind of excellence, and that kind of accountability from any other single company. You can only get it from the Harman Pro Group. So if sound matters to you, come to the Harman Pro Group. Let us perform for you.
When you play in a band on a stage, you need to be able to hear yourself. Stage monitor speakers play a special mix called a monitor mix to groups of musicians or individuals. You can set up a monitor mix using the front of house desk, the main mixer in other words, or a separate monitor desk which would normally be on the side of the stage in larger venues. If you're going to do the monitor mix from the front of house desk, use the pre-fade auxiliaries to set the level of each instrument in the monitor mix. You can have as many different monitor mixes as you have pre-fade auxiliaries on the desk. The monitor mixers come out of the desk from the pre-fade auxiliary sends. It's a good idea to put a graphic equalizer on each monitor output. Then you can ring out the system in the same way you did for the main PA. Just remember that you need to do your final ringing out with both the monitor and main PA set to their normal operating levels. There are all sorts of monitors, but the ones you'll come across most of the time are wedges. These sit on the stage and point upwards at the performers. In-ear monitoring is becoming more common and is great for sound engineers because the performers hear exactly what they want to without spill from the front of house sound, and there are no feedback issues. Thanks for watching the Soundcraft Guide to Mixing. We hope this guide has been useful and given insight into the art of mixing good sound. Soundcraft is part of the well-established international Harman group of companies. Why not check out these links for a wealth of information and professional equipment designed to help you in every aspect of your live music productions. You can download the Soundcraft Guide to Mixing booklet or take a look at the Giggers glossary. Lastly, don't forget to take a few moments to enjoy the introduction video to the Harman Pro Group. Just select the menu option you'll find on your screen. Thanks for choosing Soundcraft.